Welcome to today's video. Today we're going to be focusing on expressing the cube roots of whole numbers and integers in simplest form. We're going to show that proficiency by correctly answering 3 out of 5 questions on the exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a fresh piece of paper and we'll get you a new note sheet tomorrow. Now, when it comes to taking the cube root of numbers, it's very similar to square roots. Our first step is still going to be the same. We want to create a factor tree. We want it to break it down to all the prime numbers. The only difference, our radical symbol is now the cube root symbol, which it still has that root, but instead of not having a number in front, there's going to be a little teeny tiny 3 in the top corner. That means you want to take the cube root of it. It's now 3 numbers. Step 2, we're still going to cross out all the prime numbers. This time when we go to circle though, we want to circle triples. So anything that we have 3 of. The cubing of a number is to the 3rd power, so we need 3 of them. Our last step is still the same. Anything you did not circle stays inside the radical. Anything you circle goes on the outside, and we're still going to multiply those numbers. If we look at our first example, we're starting with the cube root of 64. So I'm going to start by breaking it down. Well, I know 8 times 8 gives me 64. 8's not prime, so we're going to go 4 times 2 and 2 times 2. I'm going to do the same thing on this side since they're the same number. From here, I'm going to cross out all my non-prime numbers. I don't need 8. I don't need 4. 2's are all prime. Now I'm going to circle my triplets. Well, I have 3 2's here, and I have 3 2's there. Everything that you did not circle goes on the inside. Well, in this case, there's nothing, and everything on the outside, everything you circle goes on the outside. 2 times 2 gives me 4. So the cube root of 64 is 4, so it is a perfect cube. Now, if we look at number 2, we want the value of the cube root of 1029 in simplest form. Well, if I start with my number 1029, I'm going to break this into 343 times 3. 343 I'm going to break down into 49 and 7. And I know 49 can break down into 7 and 7. From here, I'm going to cross out all my non-prime numbers. So we have 49 and 343. If I circle my triplets, well, I have triple 7's. And I don't have anything else to go with the 3. So, again, we want circle on the outside and non on the inside. So in this case, we circled a 7, and we did not circle a 3. Please make sure when you write your answer, I cannot stress enough, you need to make sure that you have this little 3 right there. If you do not have that little 3 right there, that means you're taking the square root of a number, and that's not the correct answer. It is not 7 times the square root of 3. It is 7 times the cube root of 3. We circled triplets. We need to put that 3 there. Now, we want to know what is the value of 2 times the cube root of negative 4,000 in simplest form. To start, I'm not even going to worry about the 2. I'm going to start with my negative 4,000. If I break it down, we have 2,002. I'm not looking at the negative quite yet. I have 1,002, 502, 5 and 100, 10 and 10, which gives me 5 and 2, and 5 and 2. Now, the one thing to keep in mind with this, when you have that negative sign, that is like saying negative 1 times negative 1 times negative 1. Because it's the cube root, we want to do it 3 times. Well, negative 1 times negative 1 times negative 1 does give me negative 1. So when I go to circle my triplets, this is now a triplet. That negative sign out front becomes 3 negative 1's. If I cross out all my non-prime numbers, and now I need to circle my other triplets. Well, we already circled negative 1. Now I'm going to circle the 2's there. I have those 3 5's. Even though they're not right next to each other, it's still a triplet. And I have 2 2's left. They can't make a triplet, so we won't worry about those. So now, if I bring my circled on the outside, I have negative 1 times 2 times 5. And then what's left on the inside, I have 2 times 2. Now, don't forget from the original problem, we need to bring down, I'll do it in a different color so we know that that's the same. We need to bring down that 2. That gets multiplied by everything that's out in front. So 2 times negative 1 times 2 times 5 gives me negative 20 times the cube root, and 2 times 2 is 4. Please, please, please do not forget, I guess, that 2 that's out in front needs to come down. And I know we talked about negatives with square roots, and it can't be done if it's underneath the radical. With cube roots, because it makes a triplets of negative 1, we can pull out that negative. And if you don't pull out that negative, it is not in simplest form. If we look at our fourth example, I want to know, is 8 times the cube root of 81 in simplest form? Again, we're going to ignore the 8 to start because we always want to focus on the number that's underneath the radical. If I break 81 up, it can become 27 and 3. Well, that becomes 9 and 3. And 3 and 3. If I cross out all my non-prime numbers, I'm going to cross out 27 and 9. From here, we circle our triplets. Well, I have 3 triplets. If I have 3 triplets, that means I'm pulling something out. So in this case, it would be 8 from the original problem times 3, and then the cube root of 3. Well, 8 times 3 is 24, and the cube root of 3. So is this in simplest form? No, it was not in simplest form. Simplest form would be 24 times the cube root of 3. If you can pull out a triplet when it comes to a cube root, it is no longer in simplest form. If you can keep going and doing the math, it's not in simplest form. It's just like square roots. The only difference is now we're talking about triplets. But simplest form is always as low as it can go without any more math being done to it. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.